So today's topic, the derivation of IDC.
Hmm.
That is my DC average current. Okay, or average DC current is but IDC. For that, I have to know some few concepts.
Hmm.
Okay. So for example, we all know what is V naught. Or else before that, I'll tell you efficiency. There is something called efficiency here.
Yes.
Correct. Efficiency is nothing but gain. In electronic efficiency is nothing but gain, that is output by input. Correct. So this
Yeah.
gain represented by something called A naught. Okay. So that is nothing but output. In the sense what here it is voltage. Output voltage to input voltage. This is my gain. So normally
Yeah.
my gain output voltage by input voltage or efficiency is output by input. Same thing only.
Yes,
Okay.
sir, yes.
So now we have to define what is an output voltage, what is input voltage. So if you take rectifier here, half a rectifier, obviously there is a sine wave.
Yeah.
Correct. Obviously
Yes.
there is a sine wave. This is an input. So output is also a wave, sine wave,
Zero.
negative.
Sine wave. Yeah.
Correct.
Negative. Yes, sir.
Correct. Negative half cycle has been cut. So the thing is
Yeah.
that here, yes. So from this actually it will start. So V naught is equal to Vm sin omega t. V naught is equal to Vm sin omega t. And if I want to just tell you, this is my 0, this is my 90 degree, pi by 2, and this is my full cycle pi.
Pi. Yeah.
And this is of the range 0 to pi. Okay. So in examination, whatever is this, and this cycle angle is theta, theta I'm just taking as omega t. Okay, 0 to pi. So these things we have to mention.
Yes,
So
sir.
that they will understand that. Correct. So for example, can you tell me what is from, let's take pi to 2 pi, what is the thing? Pi to 2 pi, what is my V naught? Pi
V
to 2
naught is Vm.
V naught. Is there anything here?
No,
Pi
nothing
to
is
pi.
there.
So 0.
0. Okay.
That's it.
Yes, sir. Yes.
Actually speaking, these are all LKG stuff. But the problem with us is this subject is so vast so that we don't go into those details. Correct?
Yes, sir.
Seeing this itself is getting scared for us.
Yeah.
Correct?
Yeah.
So that's the reason. If you are just 1 second. Sorry. Okay. Fine.
Yes.
So pi to this particular thing. Pi omega t and 2 pi. You got the point? Is it clear up to this?
Clear, sir.
Perfect. So this is my first thing. Correct. And if you ask me what is my V, obviously this is my input volt Vi.
Sir, one doubt is there, sir.
Yeah.
Like, how did you get the equation V naught equal to Vm sin
I'll
omega
come to
t?
that. I'll come to that. Okay, that is a Fourier series, so Fourier transform thing that you'll be studying in your third semester.
Okay.
There is a Fourier series and Fourier transform. I is equal I know I naught sin omega t.
Okay.
So A and B and C and that is your Fourier series and Fourier transform. These are all Fourier series equations.
Okay.
Fourier series equation which you'll be studying in your M3, third mathematics thing. Okay. Fine. So this is some of the inputs. That is an input function. This is a function.
Yes, sir.
Correct. Yeah, this is a function. F of x is there, no? Just take like that. Okay. So in physics, if you want a wave function, they'll give psi. So let me complete this. Then whatever doubts is there, we'll ask.
Yes, sir. Yes, sir. Sure, sir.
Okay. So up to this, we are clear. So V naught is fine. Now, if I'm taking I, so I is equal to similarly I am sin omega t, but instead of not, for confusion part, I'm just putting theta. If you want, you can put theta also. Okay. Okay. This is just for the positive half cycle. This again, I'm telling for this half cycle only.
Okay.
This is 0, obviously.
This is 0, yeah.
Correct. From pi to, but again, you have to write the same thing here. Correct. But I is equal to Im sin omega t for what is the interval here?
Theta is less than or greater than pi and less than or equal to 2 pi.
Very good. Very good. Very good. So in the sense, I can put less than or equal to 0 here. Correct. And less than or equal to pi.
Pi. Yeah.
Now, if it is a pi to 2 pi?
Pi and 2 pi.
Pi to 2 pi, it will be what?
0.
Very good. So now you got the thing, I is equal to 0. So these are the two things you have to note it down.
Yes, sir.
Okay. And one more thing. We have to always go for the basics. I hope you're written it down. You're written it down.
Yeah.
For the basic thing, again, I have to only follow this particular diagram. What I'm going to do now? Simple thing here. V is equal to IR. Correct. So I is equal to V by R. I is equal to V by R. So now if I want to take the load current at the load, okay, so maximum current will be at the load, IM. Or else I'm telling, if I want to find the maximum load current, to find maximum load current. Okay, if I'm giving that particular thing, it is IM is equal to V by R. Correct. So here I'll just write VM. That VM sin omega t is that particular thing. Correct. Then load resistor RL.
Okay.
Correct. Then if I want, I can put one more resistance called RF. That is nothing but forward resistance of the diode. RF is nothing but
forward resistance.
Forward resistance. Will be in the diode. Correct. Then if I want, I can put one more resistor RS, series resistance.
Series resistance. Okay, sir.
Okay, but ideally speaking, this RF value will be 0. That is for ideal.
Yeah. Okay. Because it is in forward bias, the current is flowing. So
correct. Excellent. Yes. And this RS maybe I can attach with the transformer. So that's the reason it's already inbuilt. That's the reason we are not showing in the figure also.
Okay.
Now coming to our main point, the derivation of IDC. That is our main thing. Correct. Yeah.
Yeah.
So in the thing is that we have to find, for example, again I'm coming to the figure here. We have to find the area between this, the fluctuation of current between this. Correct. Then only I can get the maximum current, the average current. What is going through this particular thing. Correct. That I have to find out. Okay. So that is my IDC thing. Okay. So I'll write here area under the curve to the time period. Okay. Area under the curve to the time period. Area under the curve to the time period. And I don't know why the handwriting is not coming that good. Maybe I had to clean the screen. Maybe. Yeah. Okay. IDC thing again coming to this. Okay. So here, as I told you, Fourier series or Fourier transform. But since you're going to learn M3, I will be doing the integration part here. Okay.
Okay.
So, yeah. If you have the, or else after this class, I'll just send you a pic of the Fourier thing. Okay. Then you will be clearer. Okay.
Yes, sir.
So normally the thing is that we know definite integral, right? So here we are, yes. So here also 0 to pi, correct? One waveform. Yes. And then what is the other waveform?
Pi to 2 pi.
But already we know pi to 2 pi. What is the value?
0.
So 0 dot d theta I will just put here. So 0 to 0 dot d theta I will put here. So obviously this part is 0. I don't need to care. So only 0 to pi. That value also I know. I am sin theta. Correct. I am sin theta d theta. So obviously I will differentiate what with respect to theta. Correct. Im is a constant. I can take it outside. So next, yes. What I'm going to do here is Im. I'll take it outside. Correct. But do not forget, this is of the cycle 1 by 2 pi. So this is what we have to remember here. 1 by 2 pi. So that is there in our Fourier series. It's a formula thing. Okay. Yeah, that I will send it to you. So that is formula 1 by 2 pi integral, the full thing actually. So it's not only for this. This is also 1 by 2 pi only. Everything is 1 by 2 pi. So 1 by 2 pi. I will put Im outside. Okay.
Integration of 0 to pi.
Theta is what? Minus cos theta.
Minus cos theta.
Then I have to just put what? 0 to pi here. That's it. Okay. So what I am going to get here is Im by 2 pi. Correct. And cos theta, what is the, we know cos pi value? We know what is cos pi value? Cos pi value. This minus sign I will put here. Okay. This
fine, sir.
Cos pi minus 1. You take in calculator and do it. Okay. And cos 0 is 1. So that we won't get the thing. If I'm able to do, you'll get minus 2, right? So I can cancel.
2 cancel,
Yes. And minus
cancel.
So I'm getting what? Im by pi. Very good. So I'm getting IDC value, I'll write it on here. IDC value is equal to IM by pi I'm getting. So this is actually, or IDC, this IM by pi, 1 by pi value is but 0.318. Again, you can use a calculator for getting this thing. Okay. Yeah. Or else you can put IM by pi itself. Not a problem. Clear up to this?
Yes, sir.
So similarly, if IM thing, can we derive the same thing we'd use for what? VDC.
VDC.
I'll get VM by pi. That's it. Same thing. That
Yes,
you know, you need not show in the examination. You got the point. That we need not show. The process is same only. Okay.
Okay.
If it is a half a rectifier, the process is same for both the things.
Yes, sir.
That we need not show.